All right, let's move on to number 21 and 22. Give me a moment to get there on my pages. All right, so where is my pen? Here we go. 21 and 22, proofs. All right, 21. Prove that the triangles below are similar and write the proof using complete sentences. Then write the similarity statement and the proportionality statement. I want to remind you of something, class. Remember, we have 3 shortcuts to prove that 2 triangles are similar. They are angle, angle, side, 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 and side, angle, side. Make sure you review those shortcuts and know how to prove using those 3 methods. Now look at number 21. We do not have all 3 sides. That means side, side, side here is out. And we only have 1 angle, so angle, angle is out. All we have possible is to use side, angle, sides. Let's try to do that. First thing I can say is I've got a congruent angle, that's for sure, and I'll write it right here. I know that angle B is congruent to angle D, and that's because we are given the measure. So we've got our A, that part is good. Now we have to see if we have 2 sides that surround that angle. We do. AB and BC are on both sides of angle B, and DE and DF are on both sides of angle D. So we've got our 2 sides that surround angle A. Now all we have to do is find out whether they are proportional. And the way we do it is circle, circle, square, square. Let's circle the biggest side here and the biggest side here. Let's put a square around the smaller of the 2 sides here and here, and let's set up the proportions. Alright, now I like to usually keep the bigger measurements on top of my ratios. It doesn't matter whether you do that or not. So let's go ahead and just do the 12 on top and see what happens. When you do side, angle, side, the cool part is you just set up a proportion and see if it's true. So circle 12 over circle, which is 16. Remember, we started with this triangle and ended with this one. 12 came from triangle 1, 16 from triangle 2. We have to go back to triangle 1 and pick up the 9, and then go to triangle 2 and write the 12. Well, let's multiply this out. 12 times 12 is 144. 16 times 9 is 144. Class, we have side proportionality. So this side and this side are proportional. We have SAS, similarity. What's our proof? Here's how we're going to write it. Let me change my pen color here. Okay, since 2 sides of one, I'm going to shortcut this, one triangle are proportional to 2 sides of the other. I can put of the other triangle, and the included angle is congruent, then the 2 triangles are similar by, oops, there's a button on my pen, and sometimes that accidentally push it and then it starts to erase instead of write. Let me fix that if I can. There we go. The 2 triangles are similar by the Sas theorem. And that's all there is to it. You have to specify first, show me the evidence. You can see that I've verified that the 2 sides are proportional. Show me the evidence that we've got an included angle that is congruent, and now we can write our proof. And our proof comes right out of our definition in our flipbook. All I did was change a couple words. I put since and then, and I mentioned the actual theorem that we used to prove they are similar. All right. Now, based on that, we can write our statement of similarity. Let's do that. I know that B and D correspond because those are the two congruent angles. Now my next letter, let's just pick one. I'm going to pick A on this triangle. To get from B to A, I passed by my circle. So I've got to go by a circle from D, so the circle gets me past here. The next point I get to is E. That must be my corresponding vertex. And then I only have one left. I have C left here, and I have F left here. There's my similarity statement. I can write it by using my circles and squares to figure out which direction to go. And now my statement of proportionality comes right from my similarity statement. BA corresponds to DE. My second and third position, AC corresponds to EF, and CB corresponds to FD. And question number 21 is done. All right, let's take a look at 22, another proof. Are the triangles similar or not? Explain how you know in complete sentences. So are they similar or not? Well, we've got our shortcuts again. Let's take a look. We've got angle, angle. We've got side, 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 and we have side, angle, side. Well, looks to me like we don't know any of the angles, and that takes out these two. And all we're left with is proving by side, side, side. Let's use our matching corresponding sides by circling the biggest side on triangle 1. Let's match it up with the biggest side on triangle 2. Now we're going to take the smallest side and put a square around it. Smallest side and put a square around it, and then our final one, it's kind of hard to do the shape, but a triangle around our middle one, or you don't have to do anything at all because the one that's not marked is the middle one. Okay, let's write some proportions. Now we can't use just a normal proportion anymore because now we have 3 different ratios we have to write. So I'm just going to find the decimal value of every ratio. Let's do circle to circle. So for this triangle, my circle is 12.5. For my other triangle, it is 10. 12.5 divided by 10 is 1.25. Let's see if the rest of my corresponding sides give me the same ratio. So I'm going to go ahead and do the small one now. I go back to, here's triangle 1, triangle 2. I go back to number 1 because that's where I started. I'll put 6. That corresponds to the 4. 6 divided by 4 is 1.5. Okay, we've got a problem. 6 over 4 is 1.5. That's our ratio. But the ratio of our bigger sides is 1.25. Class, you've just shown that these two triangles are not similar because the corresponding sides are not proportional. Now, we could have checked the last one as well. Let's check the last one. 10 over triangle to triangle, 10 over 8. That's actually equal to 1.25. So even though the largest side and the medium side are proportional, the smaller side is not. So we do not have proportionality of sides. So what we can write for our proof is, since the 3 corresponding sides are not proportional, the triangles are not similar. I just thought of something here, class. Let's go back to the previous one. Okay, I should have probably added this word. It's not as critical for SAS, but let's add this. Since 2 corresponding. The reason it's not as critical, well, no, we should say corresponding because what if you matched up the wrong sides? What if you compared 12 and 12 and 9 and 16. You would have not had similarity. So this should have been, since two corresponding sides of one triangle. In this case, we have proven they are not similar because the corresponding sides are not proportional. Be familiar with AA, SSS, and SAS, how to prove two triangles are similar with those three shortcuts, or how to use them to show that two triangles are not similar.